A compound contains only carbon, hydrogen, and oxygen. Combustion of 10.68 milligram of the compound yields 16.01 milligram carbon dioxide and 4.37 milligram of water. The molar mass of the compound is 176.1 gram per mole. What are the empirical and molecular formula of the compound? Okay, what we know here is that there is a compound. Alright, let's see MPD stands for compound. And on combustion is reaction with oxygen. We got carbon dioxide, CO2, plus water. Alright, the information before us is that it was 16.01 milligram of carbon dioxide that was produced, so we'll put 16.01. And then for water we had 4.37 milligram. 4.37. Alright, and the reacting mass of the compound is 10.68. Okay, now all of these are in milligram. Alright, so if we decide to convert all of them to grams, the ratio will not change. Alright, so even if they are all in milligram, if we convert them to grams, it would still be 10.68 grams, produce 16.01 gram, produce 4.37 gram. The reason I'm taking all of these to grams is because our molar mass here is in grams, and it will help us solve this much more easily because we'll not have to be jumping units. Okay, let's take them one after the other. Let's start with our compound. Now, the compound has a molecular mass of 176.1 gram per mole. What that means is 176 gram of the compound makes 1 mole. Now that's for the compound. 176 gram makes 1 mole. This reacting mass here of 10.68 gram would make 10.6 times 1 divided by 176. So 10.6 divide 176. Let's find out. So we have 10.6 divide 176.1 equals, let's see what we have at the beginning. We have 0.06. Alright, let me put in that 0.1 here. So we have 0.06 mole. Alright, so 0.06 mole was actually what reacted here. Let's figure out how many moles were produced here. For carbon dioxide, which is CO2, if we calculate the molar mass, carbon is 12, oxygen is 16 times 2, that is 32. So when we add them together, we have 44 grams per mole. So what that means is 44 grams is the mass of 1 mole. Therefore, these 16.01 grams that was actually produced, 16.01 gram, we make 16.01 times 1 divided by 44. So 16.01 divided by 44. All right, let's find out. 16.01 divide 44. So what we have at the beginning, 0.364. Let's call it 0.364. That is 0.364 moles. All right. So at the end of the day, 0.364 mole is actually what was produced here. Okay, let's investigate water as well. Water, we have hydrogen is 2 because it's atomic mass of 1 times 2 plus oxygen is 16. So we have the molecular mass of water to be 18 grams per mole. Having known that, means 18 grams is the mass of 1 mole. Okay, so the 4.37 gram, now grams, because we did something here, 4.37 gram will now be 4.37 times 1 divided by 18. So 4.37 divided by 18. Let's find out what that is. 4.37 divided by 18. Okay, so let's go to the beginning. 0.243. All right, that is 0.243 moles. All right, now we have our mole ratio. So our compound plus oxygen, which is combustion, yielded carbon dioxide and water. All right, so the compound actually was involved as 0.06 mole from here, and then carbon dioxide is 0.364. So 0.364, and then water at 0.243. 0.243. Okay, now if we divide through by the lowest number here is 0.06. You know, these are already a ratio. We're having decimals, which is not very comfortable. So if we divide through, we have 0.06 over 0.06. So we can have whole numbers. We have 1 here, Now we'll come to this. Since we already have this on the screen, let's just divide it by 0.06. Let's see what we have at the beginning there. 4 point. Let's just call it 4. 4. That is 0.243 over 0.06. Okay, now let's do this. That's 0.364 divide 0.06. What do we have here? 6.1, 6.01. So let's call that 6. Okay, 6. That is 0.364 over 0.06. So that's 6. So this means that this compound here, just 1 mole of it was able to produce 6 moles of carbon dioxide. All right. And in 6 moles of carbon dioxide, we have 6 atoms of carbon. So this compound originally has 6 atoms of carbon in it. It also produced 4 moles of water, each mole having 2 atoms. So definitely there was 8 atoms of hydrogen in this compound because each mole of water has 2 atoms of hydrogen. So we have H8, but we're not too sure for oxygen because these combustion components being oxygen here must have contributed to the oxygens we have here. So we just put Y. We are very sure for carbon because there is no other source of carbon in this reaction. Matter is neither created nor destroyed. So the total number of carbon here must be equal to the total number of carbon here. Total number of hydrogen here must be equal, same as oxygen. But oxygen might have come from here. Carbon and hydrogen definitely came from here, so we could tell. Let's compare this to the molecular mass. We would say 12 being the atomic mass of carbon times 6, which is 72, plus 1 atomic mass of hydrogen times 8, which is 8, plus 16 times Y, which gives 176.1. All right, so that's 16Y equals 176.1 minus 80. Let's find out what that is. 176.1 minus 80. That is 96.1. So 16Y equals 96.1. So Y is 96.1 over 16. So we divide by 16. Approximately 6. So we have 6 atoms of oxygen coming from this compound. So C6H8O6 is our molecular formula. And our empirical formula is just a ratio. So let's go to the lowest possible ratio with whole numbers. I'll divide through by 2. If I divide through by the lowest number, we'll have decimals. So I'll divide through by 2. 6 divided by 2 is 3. 8 divided by 2 is 4. 6 divided by 2, 3 again. So this is our empirical formula.